Hi everybody, I'm standing in front of the ID4 battery pack. I mentioned before that in many cases what will happen is a customer will come to us and ask us to do some different type of work than what you've seen us do in the past. This isn't just for tearing something apart, this is looking at a redesign. So our customer is SABEC. They're one of the world's largest polymer suppliers. And what they want us to do is look at this battery pack and find out how much less expensive it could possibly be if this was using a polymer solution instead of what you're looking at here, which is extrusions, castings, weldings, and a lot of screws. So let's put things into perspective. Let's start off with the Bolt battery pack. The Bolt battery pack is a 57 kilowatt hour battery pack. And it weighs about 429 kilos, which is kind of heavy. The Tesla Model 3 is 75 kilowatt hours, and it's about 442 kilograms. The Tesla Model Y is an improvement over the Model 3. It has about the same kilowatt hours, 75, but it only weighs 439 kilos. This weighs 489 kilograms for 82 kilowatt hours. So if the folks at SABEC could just take this battery pack and make it so that it's equivalent to the Tesla Model Y battery pack, you're looking at a 50 kilogram reduction in weight. Now, what does that mean? That means basically that you're looking, well, let me first off say that in general, people are saying that for a kilogram of weight reduction in an electric vehicle, you're looking at about $10. So $10 per kilogram, and a kilogram is 2.2 pounds. That means that if I can reduce this by 50 kilograms, that's $500 in savings. That's quite a bit. That's a lot. And so with that in mind, let's think about what else could be done. We're just starting here. We aren't really down the road yet, but let's think about, just keep in mind that there's a potential of $500 in weight reduction savings. So let's look at exactly what we're doing here. So number one, you're looking at a product that's got some really fancy extrusions with some fancy welding and some fancy machining, and you're also looking at some castings. So this is one type of casting, and you'll see that it's welded to this extrusion and it goes all the way across to the other side. This extrusion here is a little bit different. This extrusion goes from here to the other side, but you'll notice that it has some mounts that are a little bit different than everything that you've seen on these minor castings. If we look in the center, you look through the center through here, and now you're looking at an extrusion, and what it has are these little extensions right here that are welded in place. Those extensions have a bolt. Actually, it's a nut, sorry. It's two nuts, one on the top, one on the bottom. And what happens here is this goes all the way through to the other side, and then you have one of these 8.8 bolts. Now that probably doesn't mean a lot to everybody, but to me it means a lot. This is a very strong bolt. And you'll notice that it's necked here, which means that whoever runs this down is going to run it down to torque, so many foot-pounds or newton meters. It's going to be run down to torque, and then it's going to be clocked so much so that I stretch this part right here. That puts the bolt into what's called yield. Now yield doesn't really mean, or the plastic state. Now when you have it in the plastic state, that doesn't necessarily mean that's into the yield strength. It's basically forcing the threaded fastener to become a spring. And this is the best way to hold two parts together if you've got bolts. This arrangement is kind of sophisticated. We've never seen anything quite like this before. Now, if we look at that, then what we need to do is maybe have a look at what could happen if this thing was made out of a polymer. So the first thing we have to look at is what could be eliminated. And the very first thing would be fasteners. Now these 4 fasteners here, that would take an act of Congress to make sure that you could get rid of those. So we're not gonna talk too much about this. We're gonna talk about the bolts that are around the outside edge. So if we have a look here, we have 2 different styles of threaded fasteners. This one here is one of my favorite types of fastener if you're going to use a threaded fastener. This is called a flow drill fastener. And that means that there is no hole where this thing is going to go. It spins at a very, very high speed. And what it does, if you look right here, you can see that it's melted itself right into this extrusion, this aluminum extrusion. By using this, you can put the lid on here and it's guaranteed to stay in place. These are, like I say, one of my favorite fasteners because it doesn't require a hole. I never have to worry about lining something up. The rundown system that you use just brings them all in, runs them down, and then takes off. So it's a clever way of getting a big job out of the way. Now, you'll also notice that there's this right here, this blue stuff, okay? These are called anaerobic seals, and their job is to make sure that nothing penetrates, no water, or there's no ingress at all for air or water to come in. So you've got this the serpentine seal right here that kind of locks this whole works together. And I'm going to talk about that a little bit more in a second. Let's go to the back here. Actually, well, we can stand right here for now. If you look around here, one of the things that I really like is this spine design for the connectors. Everything's in the center. That's a really cool way of making it happen. And for those of you who are wondering what that is, that would be a bus bar, and you'll notice that it's got a little bump on the top and the bottom. That's there for thermal expansion. So, and actually just the electricity going through it. So thermally it wants to grow and contract, and basically when you send electricity through here, it also wants to get away from each other. So by having this, you mitigate the amount of, it's looking like this, but you mitigate the amount of movement that's going to be happening in those areas. And it really, by adding that, all your problems go away. So let's walk around here to the back side, and we can have a look at the next kind of interesting piece, and that's this connector right here. So again, you're looking at a tremendous number of threaded fasteners. How many got here? 2, 4, 6, 8, 10, 12, 14, 16. 16 fasteners to hold that plastic part on. But this plastic part is a good deal because all my connectors are now in one plastic injection molding. And although I'm not a big fan of threaded fasteners, and I might design this a little bit different, this is kind of something that we tell our customers to do all the time. Let's figure out how we can get all these different connectors, instead of having individual ones, let's figure out how we can put them all together and make something good happen here. So let's look at how could I possibly reduce the weight by 50 kilograms if I was redesigning this product. Well, let's think about it. I'm guessing that these screws and these screws are probably worth about maybe 1 kilo. So if I could figure out how to get rid of all these things in one fell swoop, that's one way I could make things happen. If I look at the base itself, couldn't this be something that could be made out of polymer? I mean, if I wanted to, I could make that out of polymer. If I look down here, I know that these are my inlet and outlet for the water. I could make the bottom section out of a polymer. It'll be a composite, I guarantee you that. It'll be stronger than just a neat plastic. So this is going to be something where I can make the surround out of a polymer, or like I say, a composite. And then maybe what I'd have to wick away the heat, because I'm sure, we haven't taken this apart yet, but I'm sure that when we get down here, we're going to find that these batteries are cooled bottom down. And so we're going to be looking at some sort of an aluminum tray that would be a top cap, if you like, to this composite body. Now, what could we do to get rid of other costs and weight? Well, I'd probably stick with this, because if I'm going to make a running change on a car, I am definitely not going to be changing something like that. So these would stay, but let's walk over here and have a look at what we might be able to mold in place. So could we mold in place these connections right into the body of the battery tray? I think that it might be possible. Now, I know that these are extra rigid. I know that these are here for crash worthiness, side impact, and rear impact, and you don't need it in the front, but I think there may be a bar out there as well. But at the end of the day, these kinds of things can also be done if you're using something like carbon fiber or a heavy glass fill or even a mat. These things can all be done, and I believe that by looking at what I'm, judging by what I'm looking at here, there's probably a possibility of at least getting 25 of those 50 kilos out. I think that it might be possible to even do better than that, but still, if it's only 25 kilos, that's $250 of cost reduction. So here we are at the end of this